Hello everyone, and I welcome you all to today's video. Today in this video we are going to understand the k nearest neighbors learning algorithm. We are going to understand this algorithm by solving certain assignment questions. My name is Manas Pathak and I'm a student of IIPS DAVV. So let's start. In the previous part we saw the execution of linear and logistic regression algorithms in Python. Today we are learning the k nearest neighbor algorithm. Why KNN is considered a lazy learning? Discuss k nearest neighbors. Consider the following table. It consists of height, age and weight. Weight is our target variable here. Value for 10 people. The weight value for ID 11 is missing. Predict the weight of this person ID 11 based on their height and age. So we are given this question. First, we have to understand the theoretical aspects of k nearest neighbor, and then we have to implement this algorithm for the given data. Why KNN is considered lazy? The k nearest neighbors KNN algorithm is known as a lazy learner because it does not build an intermediate model during the training phase. Instead, it simply stores the entire training dataset and defers any processing until it needs to make a prediction. So the main reason why KNN is considered a lazy learner is because there is absence of training phase in KNN algorithm. For any machine learning algorithm, there are two major phases. One is the learning phase, while the other is the one is the learning or training phase, while the other is the prediction phase. In the training phase, the algorithm learns about the data. It tries to understand the pattern, the relationship among the various variables of the data, and it tries to build a model based on this relationships and patterns. But in case of Canon, there is no such training phase, and it directly stores the entire data set into its memory, in the memory of the system, and then it directly jumps to the prediction phase where it waits for a query or a new data point to be passed to it, for which it can make the prediction. Canon is called lazy because it doesn't involve any training phase where a model is built using training data. Instead of learning patterns or relationships from data upfront as eager learners do, Canon simply memorizes all of the training examples and waits until it receives the query to perform any calculation. Hence, it doesn't learn anything from training data. So, the working of Canon can be understood as an example of a student who is an eager learner and and another student who just memorizes the subject or the stuff provided to him. As an eager learner student would try to understand the pattern and relationships to the data given to it, and it tries to build a knowledge base based on this, based on the learned patterns and relationship. So while solving any problem related to the data, it relies on the that knowledge which it has gained from learning those patterns and relationships rather than the data itself. Whereas the student who memorizes all the data majorly relies on the data itself to make certain prediction. Hence, there is no learning in k nearest neighbors algorithm. Canon finds the k closest points in training data to the new point and assigns it a label based on the majority label among those nearest neighbors. So in Canon, k refers to a integer value. We select an integer value, and based on that integer value, the k, if I have selected a value k equals to 3, then I'll find the 3 closest points in the training data to the given new point, which is passed as a query to the KNN. So it finds the closest neighbors to the k closest neighbors to the given point, and based on the labels which are assigned to those nearest neighbors, it finds the label which has to which the majority of the closest neighbors belong to, and this label is used as the label for the new point. We'll understand more about this in the next slide, which focuses upon the working of KNN. There are several consequences to this lazy behavior of KNN. It completely relies on making the prediction based on received sample data, which makes it computationally expensive, especially for large data sets, and it requires large use of memory. Now let's understand the working of KNN in more detail. It is a supervised learning algorithm generally used for classification problems. Given a positive integer k and a point x0, the KNN classifier first identifies the k points in training data most similar to x0, then estimates the conditional probability of x0 being in class J as the fraction of the k points whose value belong to J. Since KNN makes no assumptions about the underlying data distribution, it is a non-parametric instance-based learning method. So KNN is a supervised learning algorithm which is generally used for classification problems, but we can also adapt the KNN for the regression problems. In case of a regression problem, we find the target value of the target variable and we find the average of all those values, and we assign that average value to the as the target value for the new given data point. A KNN, as written here, is a supervised learning algorithm, and it is a non-parametric instance-based learning algorithm. Now let's understand the working of KNN. We select the optimal value of k, which the finding the value of k can be done using the cross validation method, or we generally take an odd value for k. To measure the similarity between training and target and training data points, Euclidean distance is widely used. Distance is calculated between data points and dataset and target point. So, as I told you, if we find the k nearest neighbors to the given data point. Now, finding its nearest neighbor to data point, we use the distance metric. For the particular distance metric we are using here is the Euclidean distance. Euclidean distance is calculated as the formula for calculating the Euclidean distance is same as the formula for calculating the length of hypotenuse of a right angled triangle. So here the distance metric is the KNN, is the Euclidean distance for KNN, which is used as a metric to find the distance between the target and all the training data set points, and based on this distance we find the minimum distances. If the value of my k is 3, then I'll find the 3 most smallest distances from the given of the given data points with the target data point, and those the values corresponding the data values corresponding to that those three smallest distances would be my nearest neighbors for the given target data point. Find the k data points with the smallest distances to the target point. These are the nearest neighbors. So as I told you, the smallest distance with the those data points which have the smallest distance bit with the data point, for which the distance Euclidean distance metric is the smallest, though those data points are my nearest neighbors. When you want to classify a data point into a category like spam or not spam, the KNN algorithm looks at the k closest points in the data set. These closest points are called neighbors. The algorithm then looks at which category the neighbors belong to and picks the one that appears the most. This is called majority voting. So for the classification problems, the majority voting mechanism is used, where the class or the label which appears most in the nearest neighbor is chosen, and it is the label which is given to the new data point. In the regression, the algorithm still looks for the k closest points, but instead of voting for a class in classification, it takes the average of those values of those k neighbors. This average is a predicted value for the new point for the algorithm. Advantages of KNN are that it is simple, easy to implement, requires only one parameter k, and works on both classification and regression problems. Whereas the disadvantages of KNN are that it is difficult to implement for large data and data having several features. It also poses the risk of overfitting. So this was all about the theoretical aspects of KNN. Now let's implement the KNN to the given data set. In this data, I have 10 data points. For each I'm given the height 8, age, and the weight, which is my target variable. Now I am supposed to find the weight for the 11th data point, which has height 5.5 and age 38. So we will start the implementation of KNN by calculating the Euclidean distance of each of the 10 data points with the 11th data point. So let's calculate the Euclidean distance for all the points first. The Euclidean distance is calculated as under root of h minus 5.5 whole square plus a minus 38 whole square, where h refers to the height and a refers to the age of different data points. So in the last column, I have the Euclidean distance for all the given 10 data points. Now, depending upon the value of k, I'll start from the smallest distance and I'll collect the data points until I have collected the k data points in from my data. Now we are using the value of k here 3. So the three closest neighbors to the given point are id equals to 6, id equals to 5 and id equals to 4. The corresponding weight for which are 60, 72 and 59. So we'll find the average of these three weights, which comes around 63.67. Hence therefore we predict the weight 63.67 for the given data point. So for the 11th data point, which has height 5.5 and age 38, the value predicted by us for weight is 63.67. So this was all about today's video. I hope you learned something from here. I would like to give my sincere gratitude to Dr. Shaligram Prajapat for guiding me throughout the semester. If you like this video, consider subscribing to my channel and liking this video. I'll see you in next video. Thank you.